All right, let's jump right in with, well, maybe the biggest question anyone can ask. Today, we're going to tackle the ultimate mystery of existence, but we're not going to do it by looking at what is. Instead, we're going to try and wrap our heads around what isn't.
You know, for centuries, this is the question that's kept philosophers, theologians, and now even scientists up at night. Why is there all of this? The universe, the stars, you, me. Why is there anything instead of just an absolute endless void, an endless nothing?
So, where do you even start with a question that massive? It turns out the whole thing really hinges on one single, deceptively simple word. Before we can even try to answer why there isn't nothing, we first have to get on the same page about what nothing actually is.
Okay, first up, let's just go with our gut feeling. I think we all have a pretty good intuitive sense of what nothing means, right? So let's put that intuition to the test with a quick thought experiment.
So, picture this. You've got a perfectly sealed room made of solid stone. There's nothing inside. Absolutely nothing. You leave, lock it up, come back an hour later, and bam. Right in the middle of the floor, there's a computer. It's on, and the screen glows with just one message: I came from nothing. So, do you believe it? Or does every single part of your brain immediately start screaming, okay, where's the trick? Who's pulling my leg? What's the real explanation?
Yeah, of course not. No way. Our rational mind just completely rejects that idea. It goes against a really basic principle of how we understand the world. And it's simple. From absolute nothing, nothing comes. You just can't get something from a total, complete absence of anything.
And that right there brings us to the classic philosophical definition of the word. When philosophers talk about nothing, they mean true non-being. We're not talking about just empty space here. We're talking about the absolute, total absence of everything. No matter, no energy, no laws of physics, not even the potential for something to exist. True non-existence.
But then, modern physics decided to jump into the ring, and suddenly the definition of nothing started to get, a lot more complicated. Some pretty prominent scientists started to claim that actually they had figured out how a universe could come from nothing. So what's the deal with that? How's that supposed to work?
This idea really hit the mainstream thanks to physicist Lawrence Krauss, and his claim was pretty bold. He basically said, hey, we don't need philosophy for this question anymore. He argued that the laws of quantum mechanics, all by themselves, show how a universe can literally just pop into existence from nothing.
Okay, but here's the catch, and it's a big one. What exactly is this scientific nothing that he's talking about? Well, it turns out it's not nothing at all. It's what's called a quantum vacuum. Think of it like a simmering, bubbling soup of fluctuating energy and physical fields, all of which are governed by pre-existing laws of physics. And right there, that's the absolute core of the problem. You've got this complex physical state, something that operates according to incredibly sophisticated mathematical laws, and it's being called nothing. So you have to ask yourself, does that really line up with the original question we were all trying to answer?
This is exactly where the whole debate kind of leaves the world of pure physics and moves into the realm of language and, basic logic. So what are we really looking at here? Is this a groundbreaking scientific answer, or is it just a clever bit of wordplay, a redefinition of the word nothing?
Let's just lay it out, side by side. It makes the disconnect really obvious. On one hand, you've got philosophical nothing, which means absolute non-existence, the absence of all things. Then, on the other hand, you have Krauss's nothing, which is a quantum vacuum, a pre-existing physical state. That's very much a something. These are two totally different concepts, just happening to share the same label.
And it's not just me saying this. The physicist and philosopher of science David Albert pointed this out perfectly. He said that these quantum vacuum states, they're just particular arrangements of simple physical stuff. He said it's got nothing to do with a creation from nothing. It's like saying a fist is created from nothing. No, it's just an arrangement of your fingers.
So really, when you get down to it, calling a quantum vacuum nothing is just a bit of linguistic gymnastics. It's exactly like saying, I had nothing for dinner last night, and boy, was it delicious. It sounds clever, sure, but it's just playing with words, and ultimately it completely sidesteps the real question by changing what the most important word means. This whole debate actually reveals something really crucial, not just about this one question, but about the nature of science itself. It highlights the kinds of questions that science is equipped to answer, and the kinds that it, just isn't. Look, science is an unbelievably powerful tool for understanding the physical world. There's no question about that. But its power comes from its focus. At its very core, science is restricted to studying things that actually exist. Things we can observe, things we can measure, things we can test.
But absolute non-being? True nothingness? By its very definition, it has no physical properties. You can't put nothing in a test tube. You can't observe it with a telescope. It's what's called a metaphysical concept. That means it's a question for philosophy. It's simply not a problem that physics can even touch. So if the original big question wasn't actually answered, then what question was? What did all this fascinating science actually tell us? And don't get me wrong, the science itself is absolutely fascinating stuff, but it just doesn't answer that original, age-old question, why is there something rather than absolute nothing? It's just not aiming at that target.
What it does do, however, is give us a really plausible hypothesis for a different, but still super important, scientific question. And that question is, how did our universe, the one full of matter and energy that we see all around us, emerge from a pre-existing, more fundamental physical state? In this case, the quantum vacuum.
And that's really the thought I want to leave you with today. When we try to tackle these massive, fundamental questions, we have to be really honest about the tools we're using and what they're capable of. Because if your answer only works by changing the very question you set out to solve, then is it really an answer at all? That's something to chew on. Until next time.